So today we're going to be in your note packet. We'll actually kind of come close to finishing up your note packet today. We'll do some more just notes on your own next week, or actually not next week we're in spring break. The week after we come back from spring break. And then looking forward, so today we're going to do some more math problems. We're going to bring in a couple of more challenging type of things. And then tomorrow's going to be a quick solve in here. So if you're not going to be here tomorrow, you're going to be missing out on a quick solve. That will also be collected. Friday, if you're not going to be here, you should have signed up yesterday for getting your test, or your quiz, I should say, your formative in the Math Resource Center, so you can take it before you go. So if you haven't done that yet, make sure you get that done. Let me know so I can get one in there ASAP. Yeah, other than that, we should have some work time today. We should get about at least a mod here of work time for working on your homework packets, which kind of made me a little cranky mood. You can probably tell it in my voice that I'm a little cranky right now because the last class, I told them to get out their homework to, start working on it, and they all started on number 1. Now, I know you guys are better than that because you guys have been working on your homework, because we could have been at least through you should be at least in the 20s by now. Okay? So if you're one of those people, probably don't want to be playing poker on your phone then during work time, or be trying to check out the fact that DC Everest has canceled after-school activities today. Okay? Right? Which they have. Okay? All well known. Okay? Just let the cards fall as they may. It's going to snow. Okay? It's not. Oh my gosh! It is snowing now. I almost said it's not snowing now, but then I turned around and suddenly it was snowing. Okay? All right? So it's going to snow. We know. We knew it was coming. Okay? No need to worry about it. We're here until they tell us not to be here. Okay? So if you're going to be here, be present. Okay? Be participating. Be active, because this stuff is on your test. Okay? And it sucks that your test is after spring break. I would have loved to have your test tomorrow. Would have loved to. But we just decided you guys it was too tight. It would have been too tight to do it. We would have been going too fast for it. So we pushed it back a week, and it just sucks. But there's nothing we can do about it. Okay? All right, so we're in our note packet today. So we're going to start with this one. Now, I want you to get this one set up. As a warm-up, I want you to set up this problem because I want to see who sees the most important word in it. Okay? There is one new important word in this problem. I want you to see who sees it. So just set it up. Don't do any calculations, because the last class got all kinds of mad at me because I showed them this one important word which changes the whole problem, and then they had to use their erasers. Okay? So an airplane wants to maintain a ground speed. The key word there, not the key word, but the key word here is maintain a ground speed of 425 miles per hour with a bearing of 330 degrees. So that means that that one is vector G from yesterday. Okay? Bearing of 330 degrees puts it up here, which makes this be my 330 degrees, which makes my trig angle here what? 120. Makes my trig angle be 120 degrees. So vector G here then would be 425 cosine of 120, 425 sine of 120. We'll start fresh. And calculator, 425 cosine of 120. I'm going to save that as O. That's going to be negative 425 over 2. Then 425 sines of 120. I'm going to save as P, and that's going to be 400, no wait, 120, plus, yep, 425 square roots of 3 over 2. Yes. Okay? Good so far. Okay? Love it. Now, we got the wind. Wind is blowing from a bearing of 145 degrees at 25 miles an hour. What's the most important word in that sentence? Most important word in that sentence. Say it loud. From. Okay? Which means 145 degree bearing is down here, correct? Where this is 145 degrees. Do we agree with that? Yes? But since it's blowing from there, that means it's actually blowing that direction. So if that's 145, then this in here, this angle in here, would be 35. 5 gets me to 150. Yep, 35 there. Which means this angle in here is 35. Which means the trig angle for my wind is 125 degrees. I'll pause for questions. Okay. So vector W then is going to be 25 cosine of 125, 25 sine of 125. 25 cosine 125. Store that one as H. Negative 14.33941. 25 sine 5, so that is I. 20.47880. Yes? Okay. A plus W is equal to G, which means then that A is going to be G minus W. Yes? Huh? O minus H. P minus I. Yes? Find me the magnitude and direction. So, magnitude of A is going to be that
So this vector is in quadrant number 2. So the reference angle that we found is there. So that means actual theta here is going to be 270 plus my reference angle. So, airspeed and direction of the plane, it is going 400.101 miles per hour at a direction of 330.312 degrees. Questions, comments, concerns, clarifications? Yes, ma'am. Whatever the answer, whatever the problem is given, that's what we want your answer in. So in this case, the problem gave me 330 degrees, so I want that kind of an angle. In the next one, it's going to give me that north-south crazy one. So then I want my answer in that north-south crazy one. Yep. Okay? Other questions? Fantastic. Let's get this one set up together. We'll do this one kind of backwards because it's that goofy, that funky one. Okay? A pilot is flying with an airspeed of 325 miles per hour, heading south 25 degrees west. However, the wind is from the north at 15 miles per hour. Find the ground speed and true course of the airplane. Okay? So my first one says that that's what the airplane is doing. So that's going to be A. It's flying with an airspeed of 325, heading south 25 degrees west, which means that this in here is 25 degrees. Which makes this trig angle here to be 245 degrees. Because 270 is straight down, we came back 25, that means 245 degrees. So A here is 325 cosine 245, 325 sine 245. Next, it said that the wind is blowing from the north. If it's from the north, it's actually going south. Do I even need a trig angle for this one? Ruh-roh. So as I was saying before I was so rudely interrupted by no evening activities today, do we need to know the trig angle here? No, because it's on one of the axes, right? So this vector W is simply just (0, -15). Okay. If it were 15 miles blowing to the east, then it would be 15, 0. If it were 15 miles an hour blowing north, it'd be 0, 15. If we're blowing west, it'd be -15, 0. Okay? Now, can you do the trig angle of 270 degrees and do all that 15 cosine 270, 15 sine 270? By all means. Okay? But make it easy on yourself. Okay? If that's an easy one, because the trig values at the 4 quadrants at north, south, east, and west are all zeros and ones, Make it easy on yourself. Okay? So with that being said, now find me the ground speed and true course of the airplane. Go. Okay, so that's what we should be at. So that's the reference angle that we found. There's where the reference angle is. Because my original angle was in south 25 degrees west, I need to find this angle. Oops, step brakes. I need to find this angle in here. So that angle is going to be 90 minus G's reference angle. And that's going to be 23.92742. So the true ground speed and course of this airplane is 338.654 miles per hour at a heading of south 23.9 degrees west. And we'll again pause for questions. Seeing and hearing none. This one is not in your note packet, but I would still like to do it. So we could go to that back page, or you could actually go at the bottom of that page that you were just on. We're going to skip that multiple courses probably for right now. So if you want to go to the bottom there. Okay. A farmer wishes to remove a stump from a field by pulling it out with his tractor. Having removed many stumps before, he estimates that he will need 6 tons of force to remove the stump. However, his tractor is only capable of pulling with a force of 7,000 pounds. So he asks his neighbor to help. Neighbor, help a neighbor. When your neighbor asks for help, you help him. Okay? His neighbor's tractor can pull with a force of 5,500 pounds. Okay? They attach the 2 tractors with a 40-degree angle between the 2 forces. Assuming that the farmer's estimate of a needed 6-ton force is correct, will the farmer be successful in removing the stump? Okay. So you've got tractor 1 pulling that way. You've got tractor 2 pulling at 40 degrees the other way. Okay. Will they combine to get more than 12,000 pounds of force? Okay. Well, let's break it down into forces. What is T1's vector? T1's vector. Shouldn't need any calculations whatsoever. T1's vector. 7,000, 0. It's going straight out to the 0 angle. Okay. T2's, tractor 2's vector. This one's going to require some calculations. Magnitude of that vector, 5,500. Direction angle of that vector, What am I going to do with those two vectors? Add them together. They're working together, right? So I'm going to add those two vectors together. And then what do I need to look for? Or what am I trying to find? What are we trying to find? The magnitude of that. So we only need to find the magnitude of this one. Do the farmers pull the stump out? Yay or nay? Pulled out? Nope, not pulled out. Stump is still in the ground. Get a bigger tractor, okay? Or call shit Bob. Okay? It's my neighbor, so he got one of the big articulated tractors. That'll pull it